Good evening, everybody. Welcome to Chem 170 with your host, me, Dr. White. Hi, everybody. Today I'll be doing the review for test 2. Let me remind you, let's go to D2L. On this Thursday, the 2nd of July. Wow, where did this year go? It's already July. It's more than half done. Wow, it went quick. I'll be giving test 2 online. Uh, I got a mistake here. This should be a 2, I believe. Nope, this should be a 3. Hold on one second. You're going to see real-time editing. All right, now it's correct. On the Thursday before the 4th of July, I will be giving test number 2. And when I do face-to-face in the summer, unfortunately, I have to give the test. Usually, if the July comes in the end of the week, 4th of July like now, I would give it on Wednesday. But anyways, that's summer. Uh, on that Thursday at 8 a.m. or earlier, I'll send out the password for the test number 2 PDF file that's password protected. Now, because Friday is the 4th of July, I can't have you have a test due that day. It's a national holiday. And therefore, I'll give you until Saturday. And something I've done different, I figured I'll give you till the end of the day, Saturday. Instead of 8 p.m., you have until 11:59 p.m. to finish test 2 and upload it as a single PDF file. All right. Now, it should take you about 45 minutes. Take as long as you need. But if you've done the practice problems, watched the video, it shouldn't take you more than 45 minutes. For those of you who have watched the video on test anxiety reduction method, don't forget to use the method. And if you need help, if you're not sure you're doing it right, reach out to me and I'll even set up a special Zoom meeting to check if you've learned how to do it right. Now, test number 2 has 9 pages, 10 problems. Number of the problems are multiple part. In Chem 170, I have never will give a multiple choice question. I don't believe in them. All right, test 2 will cover the following functional groups: alcohols, thiols, the stinky stuff, and ethers, ethylene oxide, aldehydes, and ketones. For those of you following the modules, that's 5 through 9. Now, point breakdown is different from test 1. There'll be 11 points on general knowledge, 34 points on nomenclature, and now a lot more, 60 points on reactions. And it adds up to 105. That means there's 5 bonus points. Now, one thing about the reaction, unlike test 1, where I only had 1 synthesis problem, give the starting material, I think I have 3 on test 2. Again, it's not an open notes test. And obviously, if you're here tonight, you know about tonight's review. If you're not here tonight, I'll be uploading this to my YouTube channel so you can watch the video. All right, now, let me remind you one thing. If we go to content, and let me do this. Let's go to student view. If we go to content, and here it opened up to the lectures folder, which you can, if it didn't, you click on lectures, and then you scroll down, and you'll see at the bottom a button that says load more. And let's click on it, left mouse click, and there are more folders or files. And if we look further down, you'll see I have, which I'll be using tonight. You can download this from the lecture section of D2L, but you got to click on the load more button like I just did test 2 review either as a Word document or a PDF document. All right, let's get going. But before that, everything you need to know for test number 2 is in the test number 2 review. Everything you need to know. Hint, hold on, I haven't done this in a while. Big hint. Everything you need to know is in the test number 2 review. But as I said from the first video, do the practice problems. Watching me do stuff is going to help you do it on the test that well. All right, let's go to test 2 review. Let's start from the beginning. All right, first functional group is the alcohol. And how do you name it? You find the longest chain with the carbon with the OH group. Alcohol is carbons with an OH group on it, OH called hydroxyl group. And if it's acyclic, you drop the E and add OL, and you need a number. The number is the carbon with the hydroxyl group. And you number from either end of the chain. Let me get full screen, either end of the chain, so that carbon with the OH group has the lowest number. Now, if it's in a ring and there's no other functional groups, which is how I do that in this class, you don't need a number, and the hydroxyl group carbon is always number 1. I like those special effects. Number 1, I'm ambidextrous. I am. All right, a special alcohol, phenol. Benzene ring with an OH group. The IUPAC people had said for many eons that's been called phenol. We're not going to change those organic chemists, so they kept that name. It's like benzene. All right. How do you name alcohols using what's called the common names? Well, you name the R group as an alkyl group, and at the end add the word alcohol. An example of this is rubbing alcohol, which is 70 or 90% isopropyl alcohol plus water. Ooh, that would be a general knowledge question. Can you name an alcohol? It's a product you might use, isopropyl alcohol, or a product that has an alcohol, rubbing alcohol. All right. The only reaction this semester that will be from on more than one test, this was also on test number 1, is how do you make alcohols? By the way, the word synthesis, this is a fancy word meaning to make. And how do you synthesize alcohols? One way is you take a double bond, react it with H+, which is acid catalyst, water. Remember, water is HOH. You break the pi bond, and one carbon gets the hydrogen, the other gets the hydroxyl group. And it follows Markov-Nikod's rule. The carbon with the most hydrogens gets the hydrogen, and the other carbon gets the hydroxyl group. All right, let's have some fun. Let's do some reactions of alcohols. Probably one of the more challenging you'll see this semester, but you can do it. I have faith in you. And that is dehydration of an alcohol. Dehydration means loss of water. And here you have an alcohol, carbon with hydroxyl group, and an adjacent carbon with the hydrogen. Adjacent means a carbon bonded to the carbon with the OH group. And if you take sulfuric acid and heat, that's what the little triangle is. And sometimes I'll even also write after the triangle 180 degrees, which is high heat. You'll lose water, and it follows Zasev's rule. And Zasev's rule is you get the double bond. If you have more than one choice, you get the double bond that has the most, and listen carefully, carbon atoms directly bonded to the carbons of double bond. Now, since it's a little tricky, let's do an example. It's not really tricky, it's just a little complex. having a bad triangle day. That's a better one. And I might sometimes write either degree C that way or DEG than the letter C. That means high heat. 180 degrees C is hot. Now, we look at a molecule. Oh, that reminds me. For test two and all the tests in the final, your two friends that will always help you are one, how many bonds to carbon? Four. Oh, I gotta get that finger fixed. Four. And remember, when you're changing something and writing something new, make sure the carbons you write down have only four bonds to it. If it has three, if it has five, Dr. White will start laughing first when he's grading and then mark it wrong because there's only four bonds to carbon. I gotta get that finger fixed. Anybody know a good finger fix? Never mind. All right. The other friend is, do you break carbon-carbon single bonds? And the answer is no, not in this class. And in real life, it's very rare. Other type of bonds, pi bonds, which is the double bond, or you'll learn later on carbon-oxygen bonds, carbon-nitrogen bonds. Those I can break like that. But carbon-carbon single bonds, no. So your friends are four bonds to carbon, and do you break carbon-carbon single bonds? No. All right, so if we look at this, the conditions, sulfuric acid and the high heat, and I look at the molecule and say, what's different? What's not carbon? That's actually your third friend when you're looking at organic molecules. What's not carbon? What's not hydrogen? What's not a carbon-carbon single bond? And you say, ooh, an oxygen with a hydrogen on a carbon, that's an alcohol, but the sulfuric acid and E, I'm going to write it this way, which I normally don't, but for this reaction, I will. And you lose water, and this follows Zasev's rule. And Zasev's rule is you get the alkene, the double bond that has, listen carefully, the most carbon atoms directly bonded to the carbon's double bond. Well, if we look at this molecule, here's my carbon right here with the OH group. What carbons are attached to it with hydrogens? A and B. Now, if I lose the hydrogen from A and the OH group between these two carbons, I'll form a double bond. Do you break carbon-carbon single bonds? No. So I start with four carbons. I better end up with four carbons. And between those two, just like you have here, you'll form a double bond. And I'll put in the hydrogens now. Now, if we lose the OH group and the hydrogen from B in this reaction, we'll have four carbons. But now between this and this carbon, I'll form a double bond. And now I'll put in the hydrogens. Now we have to apply Zasev's rule. I'm going Technicolor on you. Look out. In A, how many carbon atoms are directly bonded to the carbons of double bond? 1, 2. So the answer would be 2. In B, how many carbon atoms are directly bonded to the carbons of the double bond? And the answer is this. You do not count this one because it's not directly bonded. And that's a common mistake students do. So the answer in B is how many carbon atoms are directly bonded to the carbon's double bond? And the answer is 1. And now Zasev's rule is the one that's got the higher numbers, what you get. In real life, it's a little more complex, but I simplified it for this class. And now you have to use that high level math I expect of all my students and come 170, which is a greater number, 1 or 2. And hopefully I'll pick 2. Therefore, this is not the answer, and A is. And that's how you use Zasev's rule. All right, let's go through some other reactions. If you have an alcohol reacted with HX, hydrohalogen acid, and X can be chlorine, bromine, or iodine, you replace the OH group with the halogen on the carbon that had the OH group. Again, when you react an alcohol with HX, where X can be chlorine, bromine, or iodine, you replace the OH with the X on the carbon that the hydroxyl group was. Now, a special reaction when you can't use the one above, and I talked about it in the video, but I won't put the exceptions on a test, you use thionyl chloride, SOCl2. And there you replace the OH group with a chlorine. And Dr. White's work with SOCl2, it's very nasty stuff. In this weather, when you open the bottle, it starts fuming, looks like smoke. It's not really smoke, as you know, smoke, but because it reacts immediately with the water, you usually have to do it under nitrogen atmosphere so that it doesn't happen in the summer. In the winter, you can get away with it. All right, next. If you take a primary alcohol, one R group attached to the CH2 with the OH group, that's a primary alcohol. I'll never ask on test 2 or the final what's a primary, secondary, tertiary alcohol, but I will use that terminology. Now, there's certain types of chemicals called oxidizing reagents. And instead of making you learn all the different oxidizing reagents like potassium permanganate, sodium dichromate, and so on, organic chemists use abbreviation for all oxidizing reagents, O for oxygen in brackets. And when you oxidize a primary alcohol, you lose a hydrogen here, hydrogen there, and you form an aldehyde. Primary alcohol gives you an aldehyde. And we'll talk about this later in the aldehydes and ketones. Secondary alcohol, 2 R groups, they can be the same or different. Remember, R prime and R are just like in math, X and Y, but instead of numbers, they're just carbons and hydrogens. And when you have a secondary alcohol, again, lose this hydrogen, form a carbon-oxygen double bond, and now you form a ketone. And if you watch the videos, you know, I love aldehydes and ketones. They've been good to me, I've been good to them. My PhD work was with aldehydes and ketones. My first and last patents dealt with aldehydes and ketones. So they've been good to me and I've been good to them. They're my comfort functional group. Just like you have food that you eat to make you feel good, these 2 functions make me feel good. All right, let's move on. We talked about thiols. Thiol is like an alcohol, where an alcohol is ROH. Thiol, you replace the oxygen with a sulfur, RSH. The only things I ask you to learn about thiols is 1, they stink. Oh, do they stink? Think about a skunk odor. That's a thiol you're smelling. Sticky. And the other thing you should know is methane, natural gas, is odorless. But in your house today, if you have a gas leak, you'd smell it quick. That's because they put a thiol, T-butyl thiol, in natural gas. All right, next, ethers. Ethers are where you have R group, oxygen than R prime. And R prime can be the same or different. Now, I didn't teach you the IUPAC nomenclature for ethers. I talked about it, and Dr. White, I know it, but we use the common names for most ethers, and that's named the R groups that are on there, and at the very end, add the word ether. Now, the only reaction I'm going to ask you to learn for ethers is the Williamson ether synthesis, named after Dr. Williamson, who just invented it. And here you take, this is called an alkoxide, RO minus Na plus. Now, I always put charges down. If you just put RO Na, I would never mark it wrong if you were putting down the starting materials. And then you react it with R prime X. R prime X is an alkyl halide that's an R group with a halogen, and the halogens for this reaction could be chlorine, bromine, iodide. And the oxygen, by the way, organic chemists are violent. We say it attacks the R prime group carbon, bonds to the one with the, I think I'm going to sneeze. Hold on. I think I'm not going to, I just stifled the sneeze. It went away. All right. The R oxygen bonds to the carbon with the halogen. Again, in this one, this oxygen bonds to the carbon with the halogen. Then you get Na plus X minus, which is salt. NaCl, NaBr, or NaI. And that's how you make ethers. Now, something I put in here, I don't think it's that well covered at all in the books, are epoxides, and I only talked about one. And I've worked with this stuff in industry, in the chemical industry. That's called ethylene oxide. And I've been a good chemist because I haven't used the slang that organic chemists who work with ethylene oxide call it, and I won't. Not that there's anything wrong, but I'm trying to be professional with you people. If you take an alcohol and react it with one molecule of ethylene oxide, you get this ether alcohol. And these are very important molecules that are used in our daily life. When R is the N-butyl group, that's one of the main components in oven cleaner and other uses too. Now, when you take that same alcohol or an alcohol and react it now with N molecules or moles, the number in front of ethylene oxide called the coefficient is N, a number. Then you form a polyether alcohol where the repeating unit OCH2CH2 close bracket N comes from here. Now, common mistake, and I'm telling you so you don't do it, this OH group is outside the bracket. If you put it inside the bracket, I mark it wrong. So please don't do that. All right, now we go to one of my favorite areas, aldehydes and ketones. Aldehyde, carbon double bond with oxygen. On the carbon double bond to oxygen, which is called the carbonyl carbon, there's a hydrogen and an R group. Aldehyde. How do you name it? You find the longest chain with the carbon that's double bond to oxygen, the carbonyl carbon, name it as an alkane. Drop the E, add Al. There's no number because the carbonyl carbon double bond to oxygen, which is going to be the end of the chains, is always number one. I like those special effects, always number one. And you can't have an aldehyde in a ring. Now, for a ketone, you have carbon double bond to oxygen with two R groups, and they can be the same or different, which is why we have R and R prime. You find the longest chain or a ring, and you name it as an alkane or cycloalkane. Don't forget for rings, put the cyclo prefix. Drop the E at ONE. Now for acyclic, not a ring, it needs a number. Which carbon has the carbonyl carbon? That's always the lowest number possible. If you're numbering from two ends of the chain, that will always be the lowest. Now for a ring, there's no number. Why? Because the carbonyl carbon, carbon double bond oxygen is always number one. Carbonyl carbons rock. They're cool. Dr. White's having too much fun now. All right. Now, there are two special common names I want you to know. The first one is, this turns out the simplest aldehyde, R, can also be a hydrogen. And so both R and you have a hydrogen on the carbonyl carbon, carbon double bond oxygen. Nobody calls that by the IUPAC name methanal, AL ending. It's called formaldehyde. And I'm a world authority on the use of formaldehyde. In fact, a couple of years ago, I was asked to educate the lead investigator for the Select Committee of Congress looking into formaldehyde. And I spent an hour and a half on the phone with that gentleman teaching him about that, because they came to me because I know formaldehyde. My last patent, I used formaldehyde. All right, the simplest ketone is when R prime and R are both methyls, and that's called acetone. Nobody calls that 2-propanone. Nobody. It's acetone. And acetone, one place you can get it is you go to any big box store, and one of the two types of nail polish remover is acetone. And now, since the advent of nail polish that's hardened with the UV light, acetone is probably, if you go to a place like that French store, as my friend always calls it, Target, or if you go to Walmart, you'll find most of the bottles of the nail polish remover are acetone with some perfume in it. There's another one, and I'll teach you that when we get into esters. That's another functional group. Now, very important, it's in red. And very important, Dr. White's being subtle tonight. That's my abbreviation for important, is the carbonyl group. And the carbonyl group is carbon double bond to oxygen. It's not a functional group, but it's found in many key functional groups. And you'll see that in ketones and aldehydes and other ones I'll talk about in upcoming chapters. And you should know, hint, important, how to draw a carbonyl group and how to describe it with words. Carbon atom double bonded to oxygen atom. All right, now I've already gone through this in alcohols. Primary alcohol oxidized makes an aldehyde. Secondary alcohol, remember bracket, O close bracket means oxidation. You get a ketone. Now, a really cool way of making a special type of ketone is if you take benzene, and react it with, this is called an acid chloride. I wish I had more time to talk about acid chlorides when we get into the first chapter where you normally would talk about it, but I don't, because most of you are not going to become, like all of you, chemists, organic chemists. Therefore, I've decided to allot more time later on in the semester to things like fats and oils, carbohydrates, and proteins, which you will spend a lot more time with, even at home, eating them. But here we have a benzene ring acid chloride, you need aluminum trichloride catalyst, and you form an aromatic ketone. This is one of those reactions called Friedel-Crafts acylation, because our carbonyl is called an acyl group, which I really don't stress in this class. And you make a carbon-carbon single bond here. All right, let's look at some reactions. Now, here, most of these reactions react the same way for an aldehyde and ketone. And organic chemists are lazy. So to show that, if R prime is carbons, this is a ketone. If R prime is a hydrogen, this would be an aldehyde. So if I take an aldehyde or ketone, either one, react it with an alcohol, H plus is acid catalyst. Keep your eye on the carbonyl carbon, that one, because that's where the fun is. What's attached to it, our prime or H, and our double prime is still there. You get an OH group on there, and this part from the alcohol. And this is called a hemiacetal. And that's how you form it, or a hemiketal. And this in the next reaction, if you're wondering, why am I learning this stuff? Why? Well, if these two reactions didn't occur, Mother Nature, who, by the way, is the greatest of all organic chemists, would not be able to make any carbohydrates, like the good stuff in your life. Potato chips, French fries, pizza crust, bread, rice, potatoes. And that's how you make this. Now, if you take an aldehyde or ketone, and I forgot to do this, or aldehyde or ketone, and now react it with 2 molecules of an alcohol and acid catalyst. On the carbonyl carbon is still R prime or H and R double prime. And then you have 2 OR groups. And this is called an acetal or ketal. And that's how Mother Nature forms starch. And we'll talk about that later in the semester. Now, there's a special case that Dr. Herbert Stork, who was the PhD advisor of my advisor, Dr. William Roosh at Michigan State. I forgot what New York College Stork was at, but he invented, something got in my eye. Hold on 1 second. Sorry about that. He discovered if you take an aldehyde or ketone or react it with ethylene glycol and acid, you form this molecule. And it's a way of putting on what we call protecting group. And I think he won the Nobel Prize for this, but I'm not sure on that. He won American high-level prizes for discovering this years ago. And remember, it's a special case of this where the 2 alcohols are in the same molecule. Now, for some reason, students forget this bond between the 2 CH2s. You don't break carbon-carbon single bonds, and you don't break that. So remember that. All right, now once you have an acetal or ketal, and this in the next reaction give the same products essentially. The key is carbon with 2 OH, 2 oxygens single bonded to it. This case, this carbon has OR and OH. And it can have R prime or H and R double prime. Add acid, H plus, and water. And you get back the aldehyde or ketone plus the alcohol you would have used to make this hemiacetal. And this is one of the 2 reactions, how your stomach breaks down carbohydrates. If you had a piece of bread for dinner, this is going on in your stomach. By the way, if you haven't realized that, you're a walking organic chemistry plant. Reactions are going on throughout your body that are organic chemistry. A lot of them I'm teaching you this semester. So Hemiacetal, hemiketal, you get back the aldehyde or ketone or alcohol used to make that. If you take a acetal or ketal, and again, two oxygens, but now OR and OR, and R prime can be carbons or hydrogens, and R double prime is carbons with hydrogens on them. This is either an acetal or ketal. And no, I'm not asking you to learn those names in terms of functional groups, or there is functional group nomenclature for those, and I'm not asking you to learn that. What a nice guy I am. Thank you. You're welcome. But anyways, if you add it with acid and water, this breaks it down all the way to the aldehyde or ketone you would have used to form that plus the alcohol. Now, we never have to balance it, but if you notice I put a 2 up there, that's because years ago I had these twin sisters, and this was at COD, the similar, same course as 170. And when I didn't put numbers there, they got upset. And there's nothing worse than having twin sisters upset with you. So that's why you'll see a lot of times like a little 2 here. You don't have to put it in there, but if you want to, you can. So acetal, ketal, acid and water. By the way, real quick, where can you find acid and water where you are right now? Your stomach. Acid, HCl, H plus, and water. Hopefully you've been drinking your water like they tell you to. My doctor always reminds me, stay hydrated, drink a lot of water during the day. All right, let's have some real fun. And here, this deals with one of my heroes in organic chemistry, and that's Dr. Victor Grignard. And Grignard was a famous Nobel-winning French chemist, and he invented some very special reactions. The first one is making the Grignard reagent. If you take an alkyl halide, react it with magnesium, you get this Grignard. And remember, Mg is first and then X. If you have them reversed, I mark it wrong because it is. The carbon is bonded to the magnesium, and the magnesium is then bonded to the halogen. And this is called the Grignard reagent. Remember, you don't break carbon-carbon single bonds. Now, once you have a Grignard reagent, you can react it with ketones and aldehydes. And this is one of those special reactions that you can make a carbon-carbon single bond. And here, look, keep your eye on the carbonyl carbon. That's where the fun is. Now, you know I'm an organic chemist because it is fun. And what's attached to it is still attached to it, R prime or H and R double prime. And the Grignard, again, organic chemists, look out, we're violent, attacks the carbonyl carbon and bonds to it. And in the second step, you convert what you made in the first step to an alcohol. And that's why you have the acid and water. And let's do one, because students sometimes find this a challenging reaction. It's one of my favorite. I actually used it in my PhD synthesis research. So the question would be, give the organic product or products for the following. By the way, I forgot to mention, the reactions for ethylene oxide and this reaction here, I will never give them as a synthesis problem. This is cruel, unusual punishment. I think it's still outlawed by the Supreme Court, but I'm not sure. But our court, never mind, I'll keep my mouth shut. All right, let's get to work. We look at this molecule, what's different? What's not carbon? What's not hydrogen? What's not a carbon-carbon single bond? Ooh, oxygen to double bond to carbon. It's got carbons here, I'll call R prime. Carbons here are double prime. It doesn't matter which one you call R prime or R double prime. And this could have been a hydrogen, but it's not. Then the first step, and that's why one is there, we look here, what's different? Carbon, carbon. Ooh, magnesium halide. That's a Grignard reagent. Number X can be chlorine, bromine, or iodine. In our case, it is iodine. Second step, acid and water. Remember, this attacks, forms a bond. Keep your eye on the carbonyl carbon. What's attached at our prime or H, and our double prime is still there. This opens up to an alcohol, and you do that very special thing. You form a carbon-carbon single bond. And this is my R group. So here's my carbonyl carbon, carbon double bond to oxygen. I'll write that first. What's bonded to it? My R prime, which is an ethyl group. My R group, double prime methyl. I'll have an OH. And then what's my R group? Ethyl. And in one step, from two simple molecules, I've made a very complex molecule, which is the beauty. And truly, this is a beautiful reaction, the Grignard reagent. Again, you make a carbon-carbon single bond. And I should mention, if I'm going a little too fast, you can always watch this part of the video, which I'll be posting either later tonight or tomorrow morning. All right, now, carbon-oxygen double bond in a ketone or aldehyde has one pi bond and one sigma bond. And you learn from carbon-carbon double bonds, if you add hydrogen and a catalyst, you break a pi bond, and each of the carbons gets the hydrogen. Well, same thing with aldehydes and ketones. If you have an aldehyde or ketone, add hydrogen and a catalyst. Catalyst can be nickel, platinum, or palladium. You break the pi bond, and each atom of the carbon-oxygen bond gets a hydrogen. And this is a way of making alcohols from ketones or aldehydes. And I've done that. Remember, you don't break carbon-carbon single bonds. What's attached to the carbonyl carbon here is still attached here. All right, now, because if you had, you won't see it in my class, but in real life it can happen. Say you had an aldehyde or ketone and a double bond, you wanted to get rid of just the aldehyde or ketone, make it an alcohol. Well, you'd also get rid of the double bond. Well, it turns out at Purdue, a great organic chemist, Dr. H.C. Brown, in the late 1940s, discovered a reagent called lithium aluminum hydride, LiAlH4. And when taken, one first step, react an aldehyde or ketone with that. Second step, acid and water. It does the same thing as hydrogen and a catalyst and a carbonyl carbon, but lithium aluminum hydride will not attack double bonds. So here again, carbonyl, lithium aluminum hydride, second step, H plus acid, catalyst, and water, and you break the pi bond, and each atom of the carbon-oxygen double bond now get a hydrogen, and again, it's a way of making alcohols. Now, I talked about in aldehydes and ketones, the alpha carbon, the carbon bonded to the carbonyl carbon, has acidic hydrogens. And NaOH is a base, and you form the enolate anion, and that attacks other ketone, or in this case, the same aldehyde that's also in the solution, and you form a carbon oxygen single bond and the other carbonyl carbon, you open up to an alcohol. And this is called the aldol condensation. And it's another way of making something very special, something very rare, a carbon-carbon single bond. And enolate anions is what I did my PhD thesis on, very specialized ones, kinetically favored enolate anions. And so I know a lot about these, a lot. And with that, that's review number 2, but hold on, don't leave yet. I'm not done. I think we need to have some fun tonight. So let's have some fun. Let's play that fun game. Circle and name the functional group. 2 points each. So let's do 2 of them. And there you go. I'm going to let you have some fun. Remember, it's that fun game. Circle and name the functional groups, 2 points each. And give me a thumbs up or tell me when you're done. And oh, in case you missed it, we're playing that fun game, circle and name the functional group or groups, 2 points each. You done? If you're done, give me a thumbs up. Either use the emoji or if you got your video on, give me a thumbs up. All right, I think everybody's done. So it's my turn to have some fun. All right, let's take a look. What do you do to find a functional group? Look for what's different. What's not carbon, what's not hydrogen, should get your carbon-carbon single bond, should get your attention like that. And if we look here, oh, oxygen with a hydrogen on this carbon. And what is that? You don't have to write the ROH, I will. That's an alcohol. Now, methyl group is not a functional group. But if we look at this, still it's the same molecule, there's another oxygen. And notice it's bonded to this carbon and this carbon. What is that? It's an ether. So in A, you have an alcohol and ether. If this were on a test, this right here or this right here, you don't have to put down just the name and circle it. So I better circle it or I'll get it marked wrong. And if you add an extra carbon, I do not take off points. All right, let's have fun with B. All right, look for what's different. Ooh, OH on a carbon. It's an alcohol. Ooh, oxygen double bond to carbon with carbons here and here. Just so happens in the ring, R and R prime are connect together. That's a ketone. Here we have an ethyl group, and ethyl groups and alkyl groups are not functional groups. Looking for anything to, ooh, there's another oxygen here. And I have that bonded to carbonyl or oxygen to carbon with a hydrogen. And over here, I have carbons. So this is an aldehyde. And that's all the function. I think I threw everything in there but the kitchen sink. But anyways, that's how you play that fun game. Circle and name the functional group or groups, 2 points each. On a serious note, if you don't know how to identify functional groups, how can you name them? How can you understand how they react? So even though it's a fun little game, it's a very important exercise. When I look at molecules, I look at where are the functional groups, because that's where all the action is going to happen in that molecule. Everything else comes along for the ride. So with that, I'm done. If you have any questions, stick around. I'll be posting this in a video. Since I'm done, you know what I'm going to do now. Yep. Gehen gesund, which means go in health in Yiddish. After COVID struck and we went to Zoom, I started doing that because I felt that was a good thing to do, and I just never stopped. And the other thing I'm going to do is, bye now, bye. Stole that from Beverly Hillbillies. Let's see, today is Tuesday. Yep, I brought my garbage out this morning. So tomorrow I will have my office hour at 6:30. If anybody needs help, come on by. And like I said, Thursday morning, I will be giving the password for test number 2 because Friday is a holiday, July 4th. Yay. I get to go out my lawn and watch from my house, I can see my village's fireworks. And also about a block and a half away for many years now, there are a couple of houses, people who live there, I don't know who they are, who are in competition. Who can have the biggest, loudest, and most fireworks? So I get to watch all their fireworks too. And so with that, have a happy 4th. And I'm done. And I'll stick around if anybody has a last minute question.